Hello, and welcome to Team 4's Group Assessment Number 3, a risk assessment on the high-speed rail network line number 2 from Melbourne to Sydney. Our team name is We Choose to Catch the Train. Our team members are Narrowly Goodwin, Casey Jordan, and myself, Chris Platten. During this assignment, we will explore that a risk assessment needs to be resilient, robust, and adaptable. An effective risk assessment provides a framework where risk can be identified, analysed, evaluated and treated. The process used to address the risk needs to be both methodical and consistent in manner. This way, the process is repeatable and will rank the risk consequence against their likelihood so that prioritisation can be given to the risk and decisions can be made. We will touch on some geopolitical factors that may impact on the project, including business confidence, as well as economic factors, and we will also explore environmental, security and technical challenges that may be faced by the project. The Australian High-Speed Rail Network project, which was proposed by the federal government as part of the government's passenger rail agenda, includes committing to a $10 billion national rail program over the next 10 years and was announced in the 2017-2018 budget. The line will be split into two lines running the expanse of the Australian East Coast. But for this presentation, we will be focusing on line number 2, spanning some 824 kilometres from Melbourne to Sydney. The system will be modelled on the French TVG network, with trains clocking an average speed of around 300 kilometres an hour and a top speed of 350 kilometres an hour to achieve the journey's forecasted time of approximately 2 hours and 44 minutes. The railway journey along the east coast of Australia will have spectacular views of the ocean, as well as crossing 4 major rivers and travelling through farmland and native forests. One of the main drivers for this project is population growth. By 2050, the population of New South Wales and Victoria is expected to exceed 9.8 and 8.1 million respectively. The network will offer these people benefits such as improved travel time, reliability, and increased line capacity. Minimise the impact of transport on the environment, as this is currently one of the busiest air routes in Australia. Improve connectivity to the surrounding regions through integrating public transport services with the improved rail services. It will increase comfort and amenities at stations and on the trains, and unlock housing supply and job growth between Melbourne and Sydney. One of the key risks to the high-speed rail program and its successful performance are common to all major greenfield infrastructure projects, most notably a lack of certainty around future demands and revenues, and the potential for cost overruns during construction. The estimated cost of the line from Melbourne to Sydney is $50 billion, and initial studies of the economic benefits to both line users and operators will be dependent on the fares assigned to the line. The Phase 2 study commissioned by the government in 2013, based on charging competitive fares, expected operational expenses, and ancillary services such as car parking and leasing revenues from related property developments, would not deliver sufficient revenue to fully fund or recover the expected capital cost of the project in a reasonable timeframe. This conclusion was based on a forecasted financial internal rate of return, or FIRR, to be at 1%. With this low rate of return, most commercial providers of debt and equity would not fund the project. So to attract construction contractors and line operators, it is expected that the government will be required to fund the majority of the capital costs, as well as additional incentives, such as legislative changes, planning system amendments and zoning changes, fast-tracked approvals, taxation, and other financial concessions. One of the biggest security risks of the high-speed rail network is the threat of cyber attack. Australian standard AS7770 from 2018 for rail cyber security was developed to establish and standardise the requirements for implementing an effective cyber security management system for rail. This standard defined rail cyber security as the prevention of reliability, availability, maintainability and safety, or RAMS for short. This standard is related to rail control systems and the confidentiality, integrity and availability of data in ancillary systems and the privacy of customer information. All control systems within the network will need to comply with these standards. Another security risk is one of unrestricted access to the network. It is not practical to restrict access to the entire network due to the remote location of some of the lines. So guidelines will need to be developed to determine any corridor fencing requirements for deterring unintentional trespassers from the public, such as children and the elderly, as well as livestock. It will need to establish the design and maintenance requirements for fencing, including locking and signage, any public education informing the public of dangers of the rail corridors, legislation enforcing trespassing laws, and the type of fencing required, dependent on the area, for example stock or residential, urban or security fencing, as well as the different fencing requirements for different installations, such as substations, communication towers, maintenance stations, tunnels and overpasses, as well as the stations themselves. Apart from fencing, additional deterrents such as cameras can be utilised for the security of the line. The addition of security cameras and signage will act as a further deterrent to the public, as well as assist with future prosecutions of any trespassers. A further identified security risk is operating in security-sensitive areas, such as Department of Defence land at Holdsworth and Greenbank in New South Wales. The routes around these areas will incur additional costs, such as tunnelling under the Holdsworth area, which will add approximately $0.6 billion to the cost of the route.